Let's start with the. In last class, we have discussed triple integral using spherical coordinates, right? And you have told me we have revised that these are your spherical coordinates, right? In this case, this rho is the radius vector. So we'll be taking here a rho cos phi. Phi is the angle made along with z-axis and theta is the angle made along x-axis, right? So we'll be having two types of angle in spherical coordinate. One is with along z-axis, another is along x-axis. So this is how you write your spherical coordinates. And when we are taking this complete sphere, so rotation of this phi would be 0 to pi. Whatever angle you are taking along with z-axis, variation of that angle would be 0 to pi because we have started with this d, right? And in this day, if this is your z-axis and this d is what, this is the 0 to pi, right? And when I'm taking this d and I'm rotating along the 2 pi in xy plane, so angle of rotation of theta would be 0 to 2 pi for this complete sphere, right? And first octant, for the first octant we can divide the sphere into 8 octant, and for first octant you will be keeping this in your mind that theta is varying from 0 to pi by 2 and phi is also varying from pi by 2, right? Keep this mind whenever you are finding the volume of a sphere, so you can find the volume of one octant and then you can multiply it with 8, and 8 octants in one sphere, right? And if you are taking these coordinate, then value of Jacobian is rho square sine phi. Rho square sine phi, right? And if x is equal to r cos theta sine phi, y is equal to r sine theta sine phi, z is equal to cos phi, then Jacobian would be r square sine phi. And then triple integration dx dy dz would be replaced by r square sine phi dr d theta d phi. Or if you are taking z is equal to r cos theta, so sine theta would be here, and x would be r cos phi sine theta, and y is equal to r sine phi sine theta. And if this angle is theta, then Jacobian would be r square sine theta. And triple integration dx dy dz would be replaced by r square sine theta dr d phi d theta, right? Then we have discussed this example. Find the volume of sphere. So volume is given by triple integration dx into dy into dz. Then we are changing it into spherical coordinates. In spherical coordinates, you have considered here theta angle, right? So this is your z. If you are taking first octant, so I'll be writing here 8 into triple integration. We are converting x, y, z into r, theta and phi. So we'll be putting here Jacobian r square sine theta. Why theta? Because here angle is theta. Then dr, d theta, d phi. Right? Radius would be varying from 0 to a. So if written here dr, it would be varying from 0 to a, theta 0 to pi by 2, and phi is again 0 to pi by 2 because we are considering first octant, right? Or if you want to find out complete volume, so I'll be writing here integration r square sine theta dr d theta d phi. So this is the radius, so varying from 0 to a. Now this angle is theta. Theta is along z-axis. So if theta is the angle along z-axis, so its variation would be 0 to pi. And phi is angle along with x-axis, so its rotation would be 0 to 2 pi. Right? So either you can solve this or this. In both cases, answer will be same. And we have solved this integral, I think, and you know the answer would be 4 by 3 pi a cube, right? Now, come to the next. Find the volume of the ellipsoid x upon a square plus y upon b square plus z upon c square is equal to 1. Now, we know how to find the volume of a sphere. So, what will we do? We will convert this ellipsoid into equation of sphere using change of variable. So, first we will write the formula for volume, that is equal to triple integration dx dy dz. Then I will use some substitution so that it becomes a sphere, right? So I'm using change of variable. In this question we are using two time change of variable, right? First change of variable is we are putting x upon a is equal to capital X, y upon b is equal to capital Y, and z upon c is equal to z. See, you are doing here change of variable. You are converting this small dx dy dz into capital dx dy dz over the area, sorry, over the volume x square plus y square plus z square is equal to 1, right? X square plus y square plus z square is equal to 1. So now I'm writing volume is equal to triple integration. You are converting like this: small x is equal to a into capital X, small y is equal to b into capital Y, small z is equal to c into capital Z, right? So now you need Jacobian of x, y, z with respect to capital X, capital Y, capital Z. When you will be solving this, so answer would be A, B and C. कैसे करते हो आप Jacobian? Curly x upon x, a. Curly x upon capital Y, 0. Curly x upon capital Z, that is 0. Similarly, curly y, this y with respect to capital X, 0. With respect to capital Y, b. With respect to capital Z, 0. Then z with respect to capital X, 0. Z with respect to capital Y, 0. And small z with respect to capital Z is C, right? This is diagonal matrix. So value of determined would be A, B, C. So one change of variable, you are using the Jacobian over here. So it become triple integration ABC dx dy dz over x square plus y square plus z square is equal to 1 over this sphere. Right after that, this question has become evaluate this integral over the volume of sphere. Right? Abhi, if it is sphere, then you can use here polar spherical coordinates. So you will be putting x is equal to capital X is equal to r cos theta sine phi, capital Y is equal to r sine theta sine phi, and z is equal to r cos phi, right? And then Jacobian would be r square sine phi, right? So now you will be converting capital Dx, capital Dy, capital Dz will be replaced by Jacobian dr, d theta, d phi. So ABC Jacobian, it would be r square sine phi because I have chosen here phi, dr, d theta, d phi. Now, r is varying from, radius is what? 1. R is varying from 0 to 1. Multiplying with 8, it is octant. So, theta would be 0 to pi by 2 and phi would be 0 to pi by 2. So, after simplification, you will be getting answer is 4 by 3 pi a, b, c. Right? So, in this question, we have done two time change of variable. I have told you whenever you are using change of variable, so you need to add it here Jacobian, right? So first, when you are using this change of variable, so you have evaluated Jacobian as ABC, right? And after that, you are using spherical polar coordinates. So you are again putting this Jacobian over here, right? Any doubt, beta?
Excuse me, ma'am.
Bolo beta.
मैम मैम थीटा की लिमिट्स मैम 0 से पाई और मैम फाई की लिमिट 0 से पाई/2 मैं कैसे आई थी मैम, वो समझाना
अच्छा,
एक
ये
बार।
एक ऑक्टेंट है। ऑक्टेंट की बात करती हूँ। देखो, जैसे मैं एक सफेयर था, एक सर्कल होता है ना, तो सर्कल का मैंने ये क्वाड्रेंट लिया, ठीक है। इसके लिए मैं इसको किससे मल्टीप्लाई करती हूँ? 1 2 3 4, चार हो जाते हैं ना। तो मैं क्या करती हूँ, एक के लिए निकाल लेती हूँ, उसको 4 से मल्टीप्लाई कर देती हूँ। तो जब आप पहला क्वाड्रेंट लेते हो तो इस एंगल का वेरिएशन क्या है? 0 से
0 to
लेकर 90 तक,
पाई। यस मैम।
है ना। ऐसे व्हेन यू डिवाइड ए स्फीयर और लेमन इनटू 8 पार्ट, तो आपके पास एक ऑक्टेंट सा बन जाता है। थ्री डायमेंशन में ऐसे एक ऑक्टेंट बनता है। उस ऑक्टेंट में जब आप देखते हो, दिस इज योर जेड एक्सिस, दिस इज योर वाई एक्सिस एंड दिस इज योर एक्स एक्सिस, ऑल आर परपेंडिकुलर टू ईच अदर। तो ये जो ये एंगल होता है, जेड के साथ वाला भी 90 होता है और एक्स और वाई वाला भी 90 होता है, फॉर वन ऑक्टेंट ओनली। दैट इज वाई वी आर राइटिंग हियर 0 to π/2 एंड 0 to π/2। इफ यू आर टेकिंग द कंप्लीट स्फीयर, तो मैं क्या लिखूंगी? मैं 8 नहीं लिखूंगी, इंटीग्रेशन 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 ए बी सी आर स्क्वायर साइन फाई डी आर d theta and d phi. So r varying from 0 to 1, ठीक है। थीटा वुड वेरिंग फ्रॉम 0 to 2 पाई। थीटा क्या है अभी? एक्स वाई, ठीक है। मैंने क्या बताया था? इफ इट इज योर जेड एक्सिस, यू आर मेकिंग ए डी, ठीक है। आपके पास ज्योमेट्री बॉक्स में डी होता है ना, हम उस डी को यूज करते हैं। फिर इसको आप यहाँ से होल्ड करते हो और 0 से लेकर 2 पाई तक उसको रोटेट कर देते हो, तो बन जाता है स्फीयर। तो जेड एक्सिस का एंगल तो क्या आया? 0 से लेकर पाई तक। और जब इस डी को पकड़ के मैंने ऐसे स्पेस में पूरा एक्स वाई प्लेन में घुमा दिया उसको, तो वो रोटेशन क्या हुई? 0 से लेकर 2 पाई तक। तो वो जो थीटा है वो लिया आपने 0 से 2 पाई। फाई क्या लिया आपने? जेड के साथ एंगल, तो उसकी वेरिएशन रहेगी 0 से पाई। इफ यू आर टेकिंग कंप्लीट स्फीयर, तो लिमिट वुड बी these. If you are taking first octant, so limit would be 0 to π/2 and 0 to π/2, ठीक है।
ओके मैम। यस मैम।
So after solving this integral, you will be having answer 4/3 pi ABC. Any other doubt? Okay. Now come to the last application of multiple integrals. First is calculation of mass. What is the formula of density, beta? What is density?
मास अपॉन वॉल्यूम।
Mass over volume, right? Or mass over area. If we were talking about the two dimension, so it would be mass upon area. If we're talking about three dimension, so mass upon volume. So now with the help of double integral or triple integration, we will calculate mass of a body. For a plane lamina, means a thin plate, two-dimensional thin plate, density at a point px comma y be given by this rho, that is equal to function of x comma y, right? Then elementary mass at point p. Elementary mass at point P is given by rho dx into dy, because you have told me density is equal to mass per unit area or mass over area. So mass is equal to rho into area. So you will be writing here mass is equal to rho into area. Area is what? Dx into dy. When I'm talking about this, so this is a P point, very small rectangle having delta x and delta y. But I need to find out the mass of whole plate, whole lamina. So what will we do? We will integrate that. If it is over area, dx dy, so it means we need to put here double integral. So formula would be double integration rho dx dy in two dimension. Similarly, if I'm talking about any solid, so you will be telling me density is equal to mass per unit volume, right? Mass per volume. So again, formula would be rho into V. तो V की जगह फिर क्या आना चाहिए? क्या चेंज हो जाएगा हमारे फॉर्मूले में? What will be the formula for mass in three dimension? Yes, yes, beta. You know the formula for mass of lamina. In two dimension, you will be using double integral. If I'm talking about the solid, means three dimension. And you are writing here what? Volume. तो volume है तो यहाँ क्या हो जाएगा?
Triple integration dx dy dz.
Yes, triple integration rho dx dy dz. Right? So this is the for a solid. P is any point having density is given by a function x comma y comma z. Then total mass of a solid is given by triple integration rho dx dy dz. Right? So this is the formula for mass. This is for two dimension and this is for three dimension. Right? In these application everything will be checked. You know, area would be given, right? And first you will write the formula for mass if you are going to calculate the mass of a body. So you will be writing either this or double integration rho dy dx. That is completely your choice. Area would be given to you, you will be finding the limit, you will be making the vertical or horizontal strip and sliding accordingly, right? So main motive is I'll be telling you the formula, and when I'm asking the question like calculate the mass of this body over this region, so if formula you have, then you need to find out the limit and then solve that integral to get the mass of body, right? Similarly, next, moments. So formula for plane lamina means thin plate, two dimension. Moment about x-axis. Formula would be double integration y into rho into dx into dy. If you are finding the moment about x-axis, then formula would be y into rho dx dy. Similarly, if I'm writing the moment about y-axis, then formula would be double integration x rho dx dy. If you'll be taking about x-axis, so in formula you'll be writing y. If you're finding the moment along y-axis, so in formula you'll be writing x, right? Similarly, for solid, moment about yz plane. Triple integration, if I'm talking about yz plane, so you'll be writing here x rho dx dy dz. Yz है, x missing है, तो you'll be writing x over here. Similarly, moment about xz plane, so triple integration y rho dx dy dz. Similarly, moment about xy plane, what will be the formula? Xy plane,
Z rho dx dy is dz.
simple, triple integration z rho dx dy dz. इफ यू आर कंसिडरिंग वाइजर प्लेन तो याद रखना है कि फॉर्मूले में हम x लिखेंगे और रो डी एक्स डी वाई डी जेड एज इट इज चलेगा. यहाँ टू डायमेंशन था, सो रो डी एक्स डी वाई, जस्ट थ्री डायमेंशन, सो रो डी एक्स डी वाई डी जेड, right? Now, next is center of gravity. Center of gravity is what point? That point which makes whole body balanced, right? So x bar, y bar. So x bar is equal to double integration x rho dx dy divided by double integration rho dx dy. अभी ये फॉर्मूला हमने पढ़ा. What is this? This formula is for what?
Mass.
Mass. So can I write like this? X bar is equal to divided by mass. और ये भी हमने पढ़ा अभी. What is it? अभी I have discussed in previous slide. Formula was x rho dx dy. What is it? Moment about y-axis. Moment about y-axis. So can I write like that here? Capital My upon mass. Moment along y-axis upon mass. Similarly, y bar, moment about x-axis divided by mass. Right? So for finding this centroid, you need to find out moment as well as mass. Moment as well as mass. If you are finding for x bar, so you'll be writing moment about y-axis and this is moment along x-axis. Right? Similarly, in solid, X bar is equal to x rho dx dy dz upon triple rho dx dy dz. Similarly for y bar, similarly for z bar. Right? Now come to the moment of inertia. Moment of inertia of a lamina about x-axis. So moment of inertia will be represented by I x. X means about x-axis. Formula would be double integration rho y square dx dy by rho y square dx dy. Similarly, moment of inertia of lamina about y-axis. तो क्या चेंज आएगा फॉर्मूले में?
मैम वाई स्क्वायर की जगह एक्स स्क्वायर।
Simple. Double integration rho x square dx dy. Right? Similarly, for a solid, moment of inertia about x-axis. वहां आपके पास x एक्सिस में सिर्फ y कोऑर्डिनेट था. अभी 3 डायमेंशन में अगर x है तो you'll be writing here y square plus z square rho dx dy dz. Similarly, moment of inertia of a solid about y-axis. If you're taking y-axis, so in formula I'll be writing x square plus z square. Triple integration rho z square plus x square dx dy dz. Similarly, moment of inertia about z-axis. Iz is equal to triple integration rho x square plus y square dx dy dz. Right? So these are the formulas. See, in every formula, density is required. For the calculation of mass, see the formula. Calculation of mass, you will remember it like this. Okay? Rho dx dy. Rho dx dy dz. 2 dimension to area, 3 dimension over volume. In every formula, you'll be using density. Right? So density plays an important role. Now, when you're finding the moment, again, rho dx dy. If you're finding along x-axis, in formula you'll be putting y. Along y-axis, you'll be putting formula. In formula, you'll be putting x. Similarly, in this, yz plane may x, xz plane may y, and this z. And notice, rho, dx dy dz will be as it is. Similarly, centroid, you will require this. And similarly, this. Again in this formula, rho dx dy into y square. If you're finding the about x-axis. If you're finding about y-axis, so it would be rho x square dx dy. Similarly for solid. In every formula, we'll be writing this rho. So you need density in every case, right? Let us have an example based on these formulas. Consider a triangular lamina R with vertices 0, 0, 0, 3, 3, 0 and with density rho x comma y is equal to x into y, then find total mass. Then find total mass. So what is the formula for mass? This is what? Triangle here. So it is in 2 dimension. So formula would be double integration rho dx into dy. So formula would be rho double integration rho dx dy. Right? This is the formula for mass. Right? And then you'll be having 3 vertices 0, 0. So it is 0, 0, 0, 3, y coordinate 0, sorry, x coordinate 0, y coordinate is 3. So this point is 0, 3. And 3 comma 0, this is 3 comma 0. So you are joining these point and this is the line y plus x is equal to 3. When you are putting here y is equal to 0, then x is equal to 3. This point is satisfied. And when you are putting x is equal to y is equal to 0, sorry, x is equal to 0, then y would be 3, right? So both point will be satisfied by this line. And this is the line y-axis, that is equal to x is equal to 0. And this is x-axis, so y is equal to 0. Right? So you have drawn this region also. Now this is the formula rho dA. So if I'm writing rho dx dy or double integration rho dy dx. So if I'm writing dy dx, then I'm making vertical strip. Now hurry up, tell me what will be the limit of y. Yes, beta. Limits of y.
Ma'am, 0 to 3 minus x.
0 to 3 minus x, right? And what about sliding? Limit of x?
Ma'am, 0 to 3.
0 to 3. Correct. So simple 0 to 3 minus x and 0 to 3. Rho is given to you, that is x into y, dy into dx. So you will integrate, evaluate this, and answer would be 27 by 8. Right? Similarly, for the same question, find moments about x-axis and moment about y-axis. So moment about x-axis formula would be, if here is x, then formula would be y rho dA. So you'll be writing y rho dy dx. And dy dx, so we know that we are making vertical strip and limit is 0 to 3 minus x and 0 to 3. So just what is the change? You'll be multiplying this row xy with y. So it become xy square dy dx. Limit would be same. Then evaluate the integral. This would be your answer. Similarly, my, moment about y-axis. Double integration x rho x comma y dA. Right? So that would be equal to, क्या बन जाएगा इंटीग्रल? डबल इंटीग्रेशन x, this row is what? xy dy dx. We know what are the limit of y and x because same picture we have made on the last slide, 0 to 3x and 0 to 3. 0 to 3, 0 to 3x, x square y dy dx, and this would be your answer. Right? Now, next is find the center of mass x bar y bar. You do have the formula, so you will be applying the formula here and find the answer, and answer would be 6 by 5. Okay, check it, it's your homework. Now come to the next question. Suppose that q is a solid region bounded by x plus 2y plus 3z is equal to 6 and the coordinate planes and has density rho x comma y comma z is equal to x square y z, then find total mass. Right? Now tell me what formula we'll be using. What is the difference between this question and previous question?
Ma'am, in this question we do ma'am triple integration.
Triple integration, and previous question was about double integration, right?
Yes,
So
ma'am.
first of all, you need to draw this region x plus 2y plus 3z is equal to 6 and coordinate planes. Coordinate planes means x is equal to 0, y is equal to 0 and z is equal to 0. So what is the formula for mass? Triple integration rho dx dy dz, right? Triple integration rho dx dy dz. After that, we will be drawing this region. So this is your x-axis, this is your z-axis, and this is your y-axis, right? x plus 2y plus 3z is equal to 6. If I am putting here y and z both 0, then what will be the point you'll be getting on x-axis? Put y and z 0 0, because on x-axis y is 0 as well as z is 0. So when you are putting y 0 z 0, then x would be 6. So it
6.
means this point will be 6 comma 0 comma 0, right? Similarly, on y-axis, x will be 0, z will be 0. So you'll be putting x 0 or z 0. So y would be what? 2y is
3.
equal to 6, y is equal to 3. So we will be mentioning this point 0, comma 3, comma 0. Similarly, on the z-axis, we'll be putting x 0, y 0, so z would be 2. Right now, on z-axis, x will be 0, y would be 0, and z would be 2. So this point would be 0, 0, and 2. Right? Now I am joining these points. This and this and this. So it became what? This is known as a tetrahedron. Right? This solid body is having four faces. Like what? This is a line na beta. When I'm talking about this x and z plane, so in this xz plane, y would be 0, right? So when I'm putting y is equal to 0, so x plus 3z is equal to 6 is what? It's a line, na? X plus 3z is equal to 6. So I'm drawing this line. So you will be having this triangle in xz plane. This is first part, right? Similarly, when we are talking about this zy plane, so in zy plane x would be 0, so this again you'll be getting a triangle in zy plane, that is given by 2y plus 3z is equal to 6. This is the line 2y plus 3z is equal to 6, and this was your line is x plus 3z is equal to 6. And in xy plane z would be 0, so z would be 0, so this line would be x plus 2y is equal to 6. So this is your third phase, right? Now imagine in room you are sitting and you are holding one corner of room के बिल्कुल कॉर्नर पे पहुंच जाओ. एक वॉल जो आपकी लेफ्ट हैंड साइड पर है, उस वॉल पे एक ट्राइंगल बनेगा, राइट? एक ट्राइंगल आपकी राइट साइड की वॉल पे बनेगा. Getting my point? And third triangle would be on your floor. One triangle on left side, one triangle on right side, and one triangle would be on floor, right? And fourth phase, that is fourth phase that is defined by x plus 2y plus 3z is equal to 6. It is a three-dimensional. Just joint your top corner of room, top corner को you'll be joining with the floor. इस top corner को आप इस floor से join कर दोगे. So this layer would be in three-dimensional. Getting my point? One triangle, second triangle, third triangle, and fourth would be triangle, but that would be in 3 dimension. Is it clear, beta? Yes or no? No? Okay. Just find out one corner in your room. ठीक है? अच्छा, डोर के साथ वाली वॉल में बिल्कुल जो कॉर्नर आएगा ना, एज होगा, उसको होल्ड कर लो. ठीक है? वो आपका जेड एक्सिस है, इमेजिन. ठीक है? दैट इज जेड एक्सिस. उसकी साइड पे एक लेफ्ट वॉल है, एक राइट वॉल है, और नीचे फ्लोर है. लेफ्ट वॉल पे एक ट्राइंगल बनेगी, ये वाली. ठीक है? एक टॉप कॉर्नर पे आपने एक पॉइंट लिया और एक यहां कॉर्नर पे पॉइंट लिया, दोनों को ज्वाइन कर दिया आपने, तो एक वॉल पे एक ट्राइंगल बनेगी. येस और नो? टेल मी बेटा, ये ट्राइंगल समझ
Yes.
आई? ठीक है? ऐसे ही अब आप उस कॉर्नर के लेफ्ट साइड पे चले जाओ, एक बार राइट पे गए, एक बार लेफ्ट पे चले जाओ. अब लेफ्ट पे भी एक टॉप पॉइंट से लेकर उस वॉल के नीचे कोई एक रैंडम पॉइंट आपने लिया, ये 6,0,0, उसको ज्वाइन कर दो, एक ट्राइंगल दूसरी वॉल पे बन गई, बन गई। अब नीचे फ्लोर पे एक पॉइंट आपने राइट राइट साइड की वॉल पे लिया, एक पॉइंट आपने लेफ्ट साइड की वॉल पे लिया, फ्लोर पे उन दोनों पॉइंट को ज्वाइन कर दोगे तो नीचे बेस पे भी एक ट्राइंगल बन जाएगा, बन जाएगा ना बेटा। अब आपने यहां से लेकर यहां तक एक शेड लगा देनी है, आपने यहां से लेकर यहां तक की एक शीट आपने ऐसे टेढ़ी खड़ी कर देनी है बस आपने। एक ट्राइंगल आपने अपने वॉल के टॉप कॉर्नर से लिया और उसको नीचे तक ज्वाइन कर दिया, तो वो जो लेयर आएगी आपकी दैट वुड बी इन 3 डायमेंशन, जिसके एक्स वाई जेड कोऑर्डिनेट्स होंगे एट ईच एंड एवरी पॉइंट, दैट वुड बी डिफाइंड बाय दिस इक्वेशन। इज इट क्लियर? अभी ऐसा वाला टेट्राहेड्रन है, आई एम नॉट सेइंग इट प्रिज्म, ये प्रिज्म नहीं होगा, बट ऐसा वाला सिस्टम बनेगा जिसमें एक साइड वॉल की ये है, दूसरी ये है, तीसरी ये है और चौथी ये एक्चुअली वाली है। एक वॉल ये, एक वॉल ये फ्लोर आपका, और ये चौथा आपने उसको कवर कर दिया। आई होप इट इज क्लियर, गेटिंग और नॉट बेटा?
यस मैम।
बस एक ही बच्चे को समझ आया है, बाकी किसी को समझ नहीं आया? आदित्य समझ आया बेटा?
यस मैम।
Then why are you not saying कि yes मैम समझ आया? हितेश
Yes, ma'am.
समझ आया बेटा?
Yes, ma'am.
Okay. So now we will discuss the limits. So this was the formula: triple integration rho x comma y comma z into dv. And now dv would be converted into dx dy dz, and rho is what? X square y into z. So you'll be writing here triple integration x square y into z dz dy dx. So now tell me what are the limit of z, y and x. Just try. I am making a vertical strip parallel to z axis. ठीक है, ये नीचे जो एक्स वाई प्लेन पड़ा है, यहाँ z क्या है? 0. तो योर लिमिट वुड बी स्टार्टिंग फ्रॉम 0 एंड गोइंग अप टू this. Z is equal to 6 minus x minus 2y divided by 3. Right? This coordinate planes are given to you. X is equal to 0, y is equal to 0 and z is equal to 0. Z is equal to 0 means xy plane. Y is equal to 0 means xz plane. X is equal to 0 means yz plane. Right? So limit of z would be 0 to 6 minus x minus 2y upon 3. 6 minus x minus 2y upon 3. Right? Now, when you will be putting light from here, for the limit of y and x, we'll be taking the projection of this three-dimensional body on the floor. So now you tell me, when you are putting the light from this axis, from the top of this body, then what you will be observing on the floor? क्या दिखेगा बेटा फ्लोर पे?
मैम ट्राइंगल।
यस इट इज ट्राइंगल। ट्राइंगल, यही जो एक्स वाई प्लेन में जो आपने फ्लोर पे बनाया था, एक्चुअली में आपको वही रिफ्लेक्शन दिखेगी। ठीक है, सो आई विल बी मेकिंग दिस इन एक्स वाई प्लेन. This is your x and this is your y, right? And you are making this line. In xy plane, z is 0. So we have written this line is what? X plus 2y is equal to 6. Now you need limit of y. So I'll be making vertical strip parallel to y axis. Now tell me what will be the limit of y?
Ma'am, may I?
मैम 0 to
Hmm. 0
0
to,
to 6 minus x by 2.
yes, 0 to, this is x axis, so here y is equal to 0. And from here, y is equal to 6 minus x upon 2. And what about x beta? Limit of x, this
0 to
point
6.
0 0, and this point is what? 6 comma 0. So yes, sliding off this strip is from 0 to 6, right? So now I'll show you the limit. 0, z is 0 to 6 minus 2y upon 3. Limit of y is 0 to 6 minus 6 upon 2, and limit of x would be 0 to 6. Is it right? So this is the mass. You will evaluate this integral and answer would be 108 upon 35. Is it right, beta? Similarly, question can be asked like, find the volume of a tetrahedron, or find the volume of a three-dimensional body defined by this plane and coordinate plane. Right? If the same question, find the volume of tetrahedron bounded by line A, plane x plus 2y plus 3z is equal to 6 and coordinate plane. तो आपका आंसर क्या होगा? You will be writing like this: triple integration dz dy dx. This is the formula of volume. And you know that limit of z you have calculated, so you will simply write 0, 6 minus 2y minus x upon 3, right? And then y 0 to 6 minus x upon 2, and for x 0 to 6, and you will solve it. It will give you the volume of a solid bounded by x plus 2y plus 3z is equal to 6 and the coordinate planes. Coordinate planes means x is equal to 0, y is equal to 0, and z is equal to 0. Or your homework is, note it down beta, find the volume. I will ask this answer tomorrow before the class. Everyone write, find the volume of a solid bounded by x upon a plus y upon b plus z upon c is equal to 1 and coordinate planes. Again, I'm repeating, find the volume of a solid bounded by x upon a plus y upon b plus z upon c is equal to 1 and coordinate planes. Right? ठीक है? In the similar way, बिल्कुल सेम आपके पास सोल्यूशन रहेगा. सो आप कंप्लीट सॉल्व करोगे एंड मुझे कल आंसर बताओगे. राइट? नाउ कम टू द नेक्स्ट एग्जांपल. Suppose Q is a solid region bounded by x plus 2y plus 3z is equal to 6 coordinate planes, and density is given by same, find the total mass, we have done it. Along with that, find the center of mass or centroid using decimal approximation, means you need to find out your answer in decimals. So now, what is the formula for center of mass or centroid? We do have this formula: x bar upon moment along yz plane upon mass, y bar moment along xz plane upon mass, z bar moment along xy plane upon mass, right? So mass you have already calculated, and answer is, remember this, 108 upon 35. So now you need what? M, y, z. Okay, chalo, we'll be finding xy first. Moment of xy. So in this xy, formula would be z rho dv. Now you will evaluate this and let me know what will be the answer. Triple integration z into x square y into z dz dy dx. You know the limit, na? Same as in previous question. 0, 6 minus x minus 2y upon 3. And for y, it is 0, 2, 6 minus x upon 3, I think. Sorry, 2. 6 minus x upon 2. And for the limit of x is 0 to 6. Simple. Getting this integral, z rho dv, z is z as it is, rho is given as x square yz, and dv is dz dy dx, and you know the limit, same as in the previous question, and you will be solving this integral, and after solving this you will be getting mxy is 54 by 35, right? Similarly, we'll be finding xz and yz. So for mxz, formula would be triple integration y rho into dv. And for yz, formula would be triple integration x rho dv. Right? So you will do it yourself. I'll show you this answer. This mxz, myz, you have evaluated. Now, what is the formula for centroid? X bar is equal to myz upon m. So this is your myz, 243 upon 35 divided by mass, I think 108 by 35. We have calculated. So this is your x bar, 245 divided by 35 divided by mass, 108 by 35. Similarly y bar and similarly z bar. Right? Any doubt? Any doubt, beta? At any step? Okay,
No,
No,
ma'am.
ma'am.
done. So this the main thing is that you need to remember the formula and limit should be correct. And then only evaluation would be there. So these are some practice question I'll be sharing with you. You can try it, right? And you will be solving it. Answer is given, I think. जिसका नहीं होगा, I'll be sharing. Right? So I think we can start next topic. थोड़ा सा start कर लेते हैं. Next topic is your improper integral. This is the last topic for your ST. Improper integral. There are two specific functions, special function, gamma function and beta function. Gamma function and beta function, these are special type of transcendental function and defined in terms of improper definite integral, right? Gamma function and beta function, they are special type of integral functions. They are known as improper integrals. First is gamma function. Gamma function is defined as, gamma function is represented by this symbol gamma, this is known as gamma, n, that is equal to integral 0 to infinity e raised to power minus x raised to power n minus 1 into dx for n greater than 0. This is the definition of gamma function. Special type of integral, limit is 0 to infinity, e raised to power minus x raised to power n minus 1 into dx, that is equal to gamma n. Right? For the definition of gamma, remember the limit would be 0 to infinity and one exponential function would be there and one is x raised to power n minus 1. Right? Now, if I'm asking you 0 to infinity, e raised to power minus x raised to power 3 into dx. Write this integral in gamma function. So what will be the answer? Write this integral in gamma function. So what will be your answer? Compare this integral with this? 0 to infinity? Yes, we need limit 0 to infinity. E power x? Yes, we need this factor, e raised to power minus x. Then x raised to power n minus 1. And here you are having power 3. So you will be comparing it. N minus 1 is equal to 3. And this implies n is equal to 4. So this integral can be written as gamma 4. Is it clear? Okay. Similarly, I'm asking again 0 to infinity e raised to power minus x raised to power 6 dx. Write this integral in form of gamma function. Now tell me, what will be the answer?
Ma'am, gamma 7.
Gamma 7. Good. Just we will be comparing this power 6 with n minus 1. And n would be 6 plus 1. So it would be gamma 7. Right. After that, I will tell you how to evaluate this. What is the value of gamma 7? What is the value of gamma 4? Right. So in particular, I'm finding gamma 1. So for gamma 1, we'll be putting n is equal to 1. So integral is 0 to infinity, e raised to power minus x raised to power 1 minus 1, 0, that is 1 into dx is equal to, you will be integrating it, e raised to power minus x upon minus 1, then put upper limit minus lower limit. So it is minus e raised to power minus infinity minus e raised to power 0. So e raised to power minus infinity 0 minus minus plus e power 0 is 1. So ultimately gamma 1 is equal to 1. Similarly, you can find your gamma 2 by putting n is equal to 2 and so on. But we will find its reduction formula. Next is your reduction formula for gamma n. Gamma n plus 1 is equal to 0 to infinity e raised to power minus x power n into dx. This is the n. So in x power you'll be writing n minus 1. Now in this here n plus 1. So you'll be writing xn dx. And now you'll be using integration by parts, and after solving this integral becomes 0 and you will be left with only this. So you'll be keeping n outside, 0 to infinity e power minus x power n minus 1 into dx. So it become what? Gamma n. So gamma n plus 1 is equal to n gamma n. This is the reduction formula for gamma n. Now, if I'm putting n is equal to 2, sorry, n is equal to 1. So 1 plus 1, 2. Gamma 2 is equal to 1 into gamma 1. So can you tell me what will be the value of gamma 2?
Ma'am,
Gamma
1.
1, na? Because we know that gamma 1 is what? 1. 1 into 1 is 1. So gamma 2 is equal to 1. Okay. Now tell me the value of gamma 2 plus 1, that is gamma 3. Gamma 3 would be equal to, this is your n, na? N plus 1. So I'll be writing 2 gamma 1. Sorry, gamma 2. Gamma n plus 1 is equal to n gamma n. So n is here 2, 2 gamma 2. So what will be the value of gamma 3?
Ma'am, 2.
2. Gamma 2 evaluated 1. So gamma 3 is equal to 2. Similarly, gamma 4 would equal to 3 gamma 3. And gamma 3 is what? 2. So we'll be writing here 3 into 2 into 1. And that is equal to 3 factorial. If n is positive integer, so you will be writing gamma n plus 1 is equal to n factorial. Gamma 4 is equal to 3 factorial. Gamma 5 is equal to 4 factorial. Gamma 6 is equal to 5 factorial and so on. So I have asked you the question, this gamma 7. So what will be the answer? See, gamma n plus 1 is equal to n factorial. I have asked you gamma 7. So 7 can be breaked as 6 plus 1. So what will be the answer? What is n beta? N is what? 6 na?
मैम 180.
नहीं 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 बेटा, गामा n प्लस वन इज इक्वल टू n फैक्टोरियल, ये आपको रिलेशन याद रखना है. Gamma n plus is equal to n factorial. I have told you here na gamma 4 is equal to what? 3 gamma 3. And you have told me gamma 3 is what? 2 plus 1 3 na, gamma 3 is equal to 2. So 3 into 2 into 1, it become 3 factorial. Similarly, if I'm asking you gamma 5, so it would become 4 into gamma 4. Gamma 4 you have evaluated 3 factorial. So it is what? 4 into 3 factorial, that is equal to 4 factorial. So you need to remember this relation, gamma n plus 1 is equal to n factorial if n is positive integer. So gamma 7 would be equal to 6 factorial. And when I asked you this question, evaluate integral 0 to infinity e power minus x power 6 into dx. So you will be telling me this is equal to gamma 7. And what is the value of gamma 7? Yes, what is the value of gamma 7?
मैम 6 फैक्टोरियल.
Yes, it is 6 factorial. Similarly, if I'm asking you evaluate this integral 0 to infinity e power minus 6 x cube dx. So you are telling me that is equal to gamma 4, and gamma 4 is equal to what? Answer would be what?
मैम 3 फैक्टोरियल.
Yes, it is 3 factorial. It's looking like only Harinder Jeet is studying, बाकी सब कोई नहीं पढ़ रहा. Is it so? Abhishek, ID number 40.
Yes, ma'am.
Tell me, beta, what is the value of gamma 4?
Ma'am, 3 factorial.
Gamma 7?
6 factorial.
Gamma 9?
8 factorial.
Good. Keep this in mind, gamma n plus 1 is equal to n factorial. Generally, बच्चे क्या करते हैं? When I'm asking the gamma 4 ना, तो they will be writing 4 factorial by default, and this is wrong. ठीक है? If it is 4, then there would be 3 factorial. If it is 5, then it would be 4 factorial, one less than this number, right? So these are the properties of gamma. You need to remember this. First, reduction formula is gamma n plus 1 is equal to n gamma n. This is the symbol of gamma. It is not T. You will be writing n in bracket. Gamma n plus 1 is equal to n gamma n. Or if I am writing as a gamma n, so that would be equal to n minus 1 gamma n minus 1. If you are decreasing this n plus 1 with one number, so you will be decreasing this n with 1 and as well as this with 1. So gamma n would be equal to n minus 1 gamma n minus 1. If I am asking you, write the gamma 4 in terms of gamma. So what you will be doing? This is your 4. 4 minus 1, 3 and gamma 3. Right? Gamma n plus 1 is equal to n factorial. Gamma half is equal to under root pi. You need to remember these values, beta. And if n is negative, then you will be using formula in this way. Gamma n is equal to gamma n plus 1 divided by n. इसी को we will rewrite it. Gamma n is equal to gamma n plus 1 divided by n. Right? So that's all for today, beta. This we will discussing tomorrow, right? So thank you for the session.